Excuse me. Good morning. Sorry, I was coughing there. Team Impact. Going to get started here. Going to start with our next lesson, lesson 8. We're going to continue our inequalities with application and just try to apply it in word problems and so on. So anyway, remember the questions to ask when you're solving real world problems. What information are you given? So a lot of times what I like to do is circle that information, all right, underline it in specific forms. What are you solving for? And then does your solution make sense in the context of the problem? And you should do that all the time, whether it's an inequality, an equation, or just a decimal or fraction, right? So excuse me. The school football team is selling raffle tickets for a fundraiser. It costs $155 to print the tickets, and they would like to make at least $2,500 profit. How much money do they need to raise to cover the printing costs and meet their goals? So, what does the variable represent? So, the variable in this case is going to be the amount raised. Okay, and then we're going to write the inequality. So the amount raised, we're going to call that X. Remember, it costs $155 to print the tickets. So we're going to subtract $155 from it. All right, and they would like to make at least $2,500. So if you want to make at least $2,500, we're going to have that equal to, and I'm going to finish it in a minute, at least $2,500 in profit. So it's going to be, this side is going to be at least equal to that, or this side is going to be greater than that, right? And that's how we would do that. And to solve that, certainly, they're not asking us to solve it. They're just asking us to write the inequality. We would balance beam and add 155 to both sides. Okay. So let's take a look at number 2. Number 2, Westfield Junior High School is attending a field trip to the planetarium. Students must be placed into groups of 15. Groups of 15. And the planetarium can only accept up to 18 groups per day. So each of these would have 15 in it. How many students can attend the planetarium field trip, all right, each day? Okay, so what does the variable represent? Well, it represents the number of students. Okay, we're going to write an inequality. So let's think about this for a second. Students will be placed into groups of 15. We're going to have a total number. We're going to take that total number and cut it up in groups of 15, and we can have no more than 18. So let's call this X. X is the total number of students. And if we divide that total number of students by 15, because there's 15 in each group, it could be, all right, it could be less than or equal to 18, right? So when we take this total number and divide it by 15, right, this number has to be less than or equal to 18. It can't be more than 18 because they can only take 18 groups per day. Okay? All right, now we're going to get up in here and solve a little bit. All right? Excellent. Let's go. Frances is saving money for a new tablet. She needs to save $200, at least $200, and has decided to save $10 per week. How many weeks will it take before she can purchase a new tablet? So I know, this is what I know from reading. All right, she's going to save at least 200 per week, right? At least $200 total. Excuse me. Okay, they're going to save $10 per week, right? So $10 a week to get to that. All right, so let's write an inequality. I need $200. At least tells me equal. I'm saving $10 a week, so I'm going to call it 10x. 10x is going to be greater than or equal to 200, right? So this side can be equal to 200 or can't be less than, right? So if we balance beam and tee this up, the inverse of multiplication is division. This cancels. X comes down, bring your inequality down, and X is going to equal 20, all right? How many weeks? 20 weeks. Okay. Now, what I'm going to do is come over here and graph this. 20, 30, 40, 50, 60. I just counted by tens. I'm going to circle this, fill it in because of the equal, and I'm going that way. It's greater than. And I guess I skipped this. But what I need to know is how many weeks. How many weeks? Okay. So good problem there. Let's continue. Next page, flip it over. Let's get situated here. And here we go. Farmer Fran would like to build a chicken coop. She determines that the area of the coop must be a minimum, that's the smallest it could be, 300 feet square. The length is 12. Then how wide does the chicken coop need to be? Area is base times height. All right, and sketch a diagram to help, okay, if needed. I know that area is base times height. I also know I want a coop of 300 feet square, and I know the length equals 12 feet. What I need to know is the width, okay? My plan, my inequality, right? A minimum, so it's going to be at least that. So it's got to be 300 feet. A minimum tells me it could be equal to, right? Well, area is base times height. Well, it's going to be 12x is going to be what? Greater than or equal to 300, meaning that this side, all right, what number times 12 will get us to 300 or greater than? Can't be less because we need a minimum of 300 feet square. So let's go ahead and balance beam this and tee it up and divide both sides by 12, and x is going to come down. 300 divided by 12 is 25. X is greater than or equal to 25. Let's graph it. 20, 25, 30, 35, 40. Circle it. There's the equal. Fill it in. And we're going that way. Okay? We're going that way. Good stuff here. Good stuff. Let's continue. Yep. Sam is purchasing flags for his flag football team and must spend less than $55. Less than. Smaller than. If each set costs $5.50, how many flags can he purchase? He needs to spend what? Less than $55. Right? Flags cost $5.50. And what I need to know is how many. Right? How many? Right? So let's take a look here. If I can spend no more, if I can spend less than, $55, it can't be equal to that. So it's going to be less than, I know that. 550x. Right? Okay. So balance beam and tee it up. We're going to divide both sides by 550 or 5.5. You could drop that 0. X will come down. This divided by this is 10. Oops, and look what I did. It's the first time I've done it in a while, but I did it. It's less than. Okay, it's less than. Okay, so let's try and graph this. X is less than 10. 10, 9, 8, 7, 6. Circle the 10. No equal. Empty circle. Going that way. Going that way. Okay. All right, excellent. Last one. All right, it costs 30 cents per minute to make an international phone call. How many minutes could a caller talk if they could spend $21 at most on a call? What I know, you have $21 to spend. Right? I also know it's 30 cents per minute. What I need to know is how many minutes can the caller talk, right? How many minutes? So how many minutes can I speak to spend $21? I can spend $21, but not more. So when I say I could spend it, right now I know I have an equal. So let's set this up. $21.30 times what number is less than or equal to $21? All right, can spend no more than that, right? 21. You got the idea. Divide both sides by 30 cents. X is less than or equal to. And again, this is calculator stuff here, right? So this divided by 30 hundredths is 70. And let's do our graphing over here, right? And our graphing looks like so. 80, 70, 60, 50, 40. Circle the 70, fill it in. And we're going that way. Okay. So good lesson, good application, setting it up. Make sure you're filling out your information, showing your work, graphing your solution, a lot of stuff going on here, But one of the biggest things is when you come to your pieces of information, and a lot of times I don't do this, underline or circle it so it jumps out, or even highlight, that would help. Let's flip the page and take a look at your homework. Homework 8, okay, application of inequalities. You've got 6 problems. All right, and you've got a database, all right, for the California Cafe, and enjoy. This will be due on Wednesday. Take care, guys.